Good evening, guys. Am I audible? Is my screen visible? Okay, you are getting the same predicted answer for different values. So you have to check various parameters actually. So what is your x value? What is your y value actually? So in x you should have the feature, and it is a used car data set, right? So in y you should have the output, which will be the selling price, I think so. It is a regression problem. So you have to do the x train, x test, y train, y test separately and correctly, and you have to verify their shape, okay? And you have to choose the regression algorithm. So if you have choose some other thing, you would have got some errors, okay? Please check these things. So if you still have any issues, in LinkedIn you can find me and you can contact me there. I'll help you to sort the error, okay? You can just share your file or code, okay? I'll try to sort it down. Good evening guys. So I hope I am audible. So today is an interesting class, guys. So today is day 16 of this data science Naan Mudhalvan Virtual Internship. I welcome you all on behalf of pantech elearning, and today we are going to cover introduction of deep learning. So today there is no hands-on actually. Tomorrow we are going to go in hands-on, but we are going to start the deep learning basics, okay? So when you go for deep learning, this is the first time we are going to go into the deep learning, and there are various new terms you want to understand. So usually many people what they do is, so this deep learning is nothing but instead of machine learning algorithms, okay, we are going to create some neural networks which will do the same task anyway, okay? There are some different methods, but the primary output is whether it is a classification or regression, something like that only. The prediction, that's why we are using deep learning. So many people, okay, what they will do is, they know how to import the library and how to perform the things, okay, but they don't know what is the math or what is the thing behind it. So if you don't know that, okay, you can just do with machine learning, because in machine learning you can just simply import the algorithms and perform the task. It is not that much important fact. But when you go for deep learning, there are various parameters you want to understand first. Then only you can try and get what is the thing you have to imply, okay? So you should have the basic understanding, which many people don't go or give importance in that. So we are going to start the introduction of deep learning and know all the basic things which you want to know. So in tomorrow's class, when we go for applying the neural networks in a project, okay, there you can actually imply based on the problem what you have learned in today's class, you can imply it in tomorrow's hands-on session, okay? So give me thumbs up, guys. Can we start with the class? Can we go and see the introduction, guys? We'll go in the hierarchy level from the start till end, okay? There are many things you want to understand. I'll try to simplify it, okay? In the very basic level, we'll try to understand what is the thing behind it, okay? Can we start, guys? Okay, fine. We'll start with the class. So please try to do the assignments, okay? Yesterday I have given you a basic machine learning assignment. It is a regression problem. Try to import the regression algorithm, okay, and perform the task. So we will be having 2 days left for submitting the assignment. Today is day 16. Please try to complete it by day 18, okay? Don't take after that. So starting with deep learning. Okay, so when we see about the introduction of machine learning, I told you deep learning is also a part of machine learning. So where in machine learning we are using algorithms, okay, but in deep learning we are going to use something known as neural networks. So starting with the deep learning, it is a subset of machine learning that involves the use of artificial neural network, okay, to model, okay, and solve the complex problem. The output is same, but we are going to use something new which is known as this artificial neural networks. So these neural networks are composed of many layers of interconnected nodes, okay, which allows them to learn increasingly sophisticated representation of data over time. So when it keep on running, it is trying to improve it itself. So deep learning has been used to achieve state-of-art result in a wide range of fields, including computer vision, natural language processing, speech recognition, robotics, etc. So when you think about neural networks, okay, it is created to mimic the human brain. So how a human brain acts, we are having in our brain we are having something known as neurons. So similarly, in this neural network is a combination of neuron. For example, see here guys, this is what a neural network will look like. Okay, these circles, these are called as neurons. I'll tell you what a single neuron is, but it is like interconnected, where we are having some input layer and we are having some hidden layers, and finally we are having some output layers, where these hidden layers are doing some sort of tasks. Okay, what they are doing, how they are doing, we'll learn about it. Finally, we'll be getting the output. So output can be a classification or regression or multi-class classification, binary classification, etc. So when you think about neuron, what it is? See here, for example, these are the inputs x1, x2, x3. Okay, you will be having many inputs. So you are giving that to a neuron, and it is doing something and giving you an output y. So something is happening in this neuron. Okay, so what is happening? It is doing some sort of task like wait. Okay, it is like going to add them and do some activation function and give you the output. We'll discuss about this. But anyway, this neuron is something like it will get the input and pass the output. Okay, if you connect these neurons in this way, this is called as a perceptron. Okay, it is a single layer. Okay, it is getting the input, giving you the output. So this is what a neural network is. So if you are having many neurons, okay, for example, if it is an input layer, this will get input from the user, which means you are giving some data. So this will do some task and give it to the next neuron here. This will do some task and give it to the next neuron. So these things, they'll do some task and give it to the next neuron, and it will keep on passing till you reach the output. Finally, you will get the answer. Okay, so your neuron gets an input, do some task and gives the output. What it is doing, we'll learn that. Clear? So in neural network, a neuron is a basic unit that receives input from other neuron or from external data. So if it is an input layer, it receives from the external data, or if it is here, it is going to receive from another neuron. So the output of one neuron can be connected to the input of another neuron. From one output, it is going to another one's input, forming a network of interconnected neurons that can recognize pattern and make prediction based on the data. So a typical artificial neural network consists of input layer, hidden layer and output layer. And it is supported by some functions known as activation function, loss function and optimizations. We are going to learn these things in today's class. So we are having an input layer which gets the input. We are having some hidden layers. These are all made of neuron and interconnected, and finally an output layer. So regarding the input layer, it receives data from like the user. Okay. And the hidden layer are where the network learns to recognize complex pattern in the input data. So each neuron in the hidden layer receives input from the neuron from the previous layer and produces output to the next layer. Finally, this output layer gives you the output, whether it can be a prediction or classification. Okay. So is it clear guys till now regarding the introduction of neuron and neural network? Can we go a little bit deep inside? Waiting for your response guys. Please be interactive in chat box. So there is something known as single layer neural network. So what it is? In the place of hidden layer, you will be having an input layer and output layer. These are constant. But in between, if you are having a single layer, okay, only one hidden layer, then it is called a single layer neural network. If you are having multiple things like this one, it is called as multi-layer. Okay. So this is what a multi-layer neural network will look like. It is having many number of neurons. This you can decide how much you want to keep, how much layer you are going to set. It is based on your wish. Okay. So these things are doing some tasks. Now it's time to learn about what they are doing actually, right? So you know how it is working. We are just interconnecting them, getting the input and doing something, giving the output. It can be a single layer or multi-layer. What is the advantage of multi-layer? Furthermore processing can happen. Okay. This single layer does some task. If you are having another layer, it is going to improve its accuracy or efficacy. Okay. Moving into what happens in a neural network. So for this, you have to understand what happens in a neuron. Then you can understand what is happening totally. So in neuron, you are getting some input and you are giving some output. So how it is happening? For example, you are having n number of features. Okay, this x1, x2 up to n are your features. Okay, so you are giving that to the model or sorry to the neuron. Okay, so before giving that, you are adding something known as weight. Okay, some weight is added to each input. Okay, w1 for this one, w2 for this one, w3 for this one, it's keep on adding for this each one. So what will happen in this neuron is all of these, okay, so I'll tell you. So before that, some weight is adding, and finally once the weight is added with the input, something known as bias is added here, okay, a bias is added here, and once they are done, they are going to sum it, and it is passed through some function which is known as activation function. Finally you got some output. Okay, this is what a single neuron will do. It will get input, add weight to it, add bias to it, do some function and give the output. So what is known as weight, what is known as bias, what is known as activation function. Okay, can we start with these tasks, guys? You want to know what is weight, what is bias, what is activation function. So starting with weight. So weight represents the strength of connection between neurons. Okay, weight is a scalar value that multiplies the input of a neuron to produce its output. For example, if you are passing this x1, okay, and if you want to give less importance to this one, you can give like this 0.5% of this x1. So if you multiply 0.5 with x1, its value will go low. Okay, if you multiply 0.95 with x2, okay, w2 is 0.95, this is given more weightage. Okay, this value will be high. So how much you are going to imply, okay, based on the importance, that will consider as a weight. Okay, that's what a weight is. I hope you can understand what is a weight you are actually giving. So weight is multiplied with the x1 input. Okay, see here, weight is multiplied by input. And what is bias? Bias is a scalar value that added to the weighted sum of the input to shift the activation function. So together the weight and bias control the behavior. Okay, so once you multiply with weight, okay, once this is done, it is going to add all of those. Okay, this x1 w1, x2 w2, all of those things gets added. This is summation. Once it got added, some bias is added. So why this bias is added means this bias is a constant value. Okay guys, imagine if you are having, when you add all these things, your input features are 0, for example, everything is 0. If you add all these things, you get 0. Without bias, if you pass this since it is a 0, there will be no output for you. Okay, so to avoid this condition, some bias is added. This is a constant value, just they are adding constantly for everything. Okay, to avoid that 0 error on something. Once it is done, it is going to get added, and then we are passing it into something known as activation function. So what is this activation function is doing? I hope you are clear with weight and bias. Here we are doing the summation of weight and input plus the bias value. And what is known as activation function, guys? There is something is happening in this activation function. See here, guys, this y value is the summation of weight multiplied by input plus the bias value. Okay, now this thing is represented here. Okay, this is passed through an activation function. Okay, something is applied on this value, activation function. So this activation function are mathematical equation, okay, that determine the output of a neural network, like yes or no, or it maps the value between 0 to 1 or -1 to 1, etc. So these are common term. You are given options like sigmoid, relu, softmax, some other activation functions are there, and there are certain specific cases when you have to use it. Okay, so this do some task, okay, based on it, it is going to perform some task and give you the output. That's what an activation function is. You have to select based on the problem you are going to solve. So we are going to see detailedly about these things. So this is how a neural network will work. For example, you are having a x1 value, a weight will get added to it and bias will get added, and the activation function will do some task and give the output. Then a weight to add it to this output, here also will get an output, right? Here also a weight will add it. These two things will go, okay, and activation function finally will be happening and give you the output. Clear how this weight, bias and activation function are performing? Is it clear, guys? These three terms, how a neuron is working, so how it is happening? When you go for a neural network, you will be having the input, you do that task, you will be getting an output. But with that output, you again perform the same task, add weight and bias, okay, add weight and bias, and then pass it to the function, activation function, and get the output, finally in the output layer. But what is the value you are going to give for weight, what is the optimum value you are going to give for bias, that we are going to discuss now. So can I get confirmation, guys? Is it clear regarding these three terms? Weight, bias, activation function. So I need your confirmation to continue with the next one. So we are going to go furthermore deep inside this task. Okay, as I told you earlier, imagine a situation, okay, why bias is added. imagine your input is 0. Okay, if your input is 0, if you are giving an input is 0, then obviously when you multiply it with weight, it will be also 0. Then if you pass this, there will be no such thing you can perform. Okay, so to avoid that, we are going to add some concept known as bias. Okay, so this will help you to avoid that situation, because if it is some value, since we are multiplying x1 with w1, but we are adding that with bias. If you are multiplying with bias, then this will also become 0, but we are adding the bias. See here, weights multiplied by input. If it is 0, you will be getting the base value bias as the value of y. Okay, but if you don't have this can be become 0 in many cases. So to avoid that only, we are actually adding the bias. If you multiply that, it will become also 0, totally it will be 0, then no use of it. So there is something known as forward propagation, guys. So you have to understand these tasks. Forward propagation. So it is the process of passing data through a neural network to produce an output. For example, you are giving 4 input, and you are having 2 hidden layer with 3 neurons each, and you are having an output layer 1 output. Okay. So for example, this is x1, x2, x3, x4. Some weight is get added. Okay. It is passed here. Here activation function is done in these 3 things. A bias is added and activation function is done, and this is giving an output. This is giving an output. This is giving an output. So from these 3 output, okay, it is passed to another neuron where some weight is added from this input. Bias is added. Activation is done in these 3. Finally, they are giving their weight. Okay. Finally, they are giving their output. These 3 things. So based on it, a weight is added. Bias is added. Activation function is done to get the final output. So this one step, from going from the input till the output, is called as forward propagation. Okay, and tell me guys, if you are like, the machine or the neural network is randomly giving some value for this weight. Okay, this one it has given a weight of 0.2, this it has given a weight of 0.4, but with this combo, okay, it is not actually getting a good output. So it wants to improve it. How it is going to improve? So it is called as back propagation. So we'll see about that. Before that, you have to understand the loss function. I hope you understand about the forward propagation from input till output. It is called as forward propagation. Once you got the output, okay, you are going to predict the loss. So what is this loss? For example, I'll tell you guys, you are doing a classification problem and your output can be either 1 or 0. Imagine the situation, you are performing a classification problem and your output can be 1 or 0. Okay, your original answer is 1. Okay, your y original value is 1, but the y predicted value is 0. The neural network predicted y as 0, but you have the answer as 1. When you perform the loss calculation, the loss is 1. Okay, totally 1. Y predicted value minus the y original value, you got 1. So the last value should be 0 or near to 0. So then only your neural network is performing very well. Here it is nearly 100% completely wrong. So how are you going to improve that? So a loss function is a mathematical function that measures the difference between the predicted output of a machine learning model and the actual output. Okay, what is the original output, what is the output by the machine? So once a forward propagation is done, here you will be having an output which will be compared with the original answer, and a loss value is calculated. Okay, you will be having a loss value. Next comes the task which is known as back propagation. Once a forward propagation is done and the loss is calculated, okay, to reduce that loss, what this neural network will do, it will do back propagation. Okay, so the weight and bias are adjusted. This weight and bias are actually deciding factor in the output, right? They are only gets added, multiplied and deciding the output. So they are going to do different combination and try to get or minimize the loss in the output. Okay, so the weight and bias are adjusted based on the error between the predicted output and actual output. So based on the loss, they are actually going to update the weight and bias by doing it one step back. So from the output layer, it will go to this hidden layer, from that to the input layer, then it will change and then come back. Okay, so another forward propagation will happen. It will try to improve the output, reduce the loss, go back again, come back again, go back again. It will do the forward and backward propagation. So it works by propagating the error backward through the neural network, starting from the output till the input. Okay, that's what one backward propagation will do. How these are getting added or adjusted, we'll learn about it. So how weights and bias are adjusted. So if you are going through the back propagation, how are you going to adjust it so that you can get minimal loss in the end? So optimizers, something known as optimizers are used here. What is optimizer? They are going to optimize the weight and bias, or algorithms that are used to adjust the weight and bias in a neural network during training. Okay, with the goal of minimizing the loss function. You want to just minimize the loss. The weight and bias are updated via a chain rule of differentiation. There is something known as chain rule. We'll discuss about that. Optimizers use a hyperparameter known as learning rate. So based on this learning rate, they are going to update the weights and bias. So the ultimate aim is to reduce the loss function. Okay, optimizers will do it. So one of the example of optimizer is gradient descent. So this will be your minimal loss value. Okay, if you are, for example, this is known as minimal, global minima they used to say. Okay, and this will be the lowest you can achieve. And how are you going to achieve it? You are going to achieve through a gradient descent. In this, if you are using gradient descent optimizer, it is going to adjust the weight little by little so that you can completely get a lowest value from here to here, gradiently descending. Okay, there are some other optimizers too, we will discuss about that. So this is how you are actually reducing the loss, by adjusting the weight and bias. Okay, clear? And as I told you earlier, how they are adjusting, they are going to adjust with the help of chain rule. Here the weights and bias are updated via chain rule. What is that chain rule? You would have learned in mathematics. Okay, so for example, if see here, this red line is the backward propagation. It is going to take differentiation. Okay, where this based on the output, it is going to take differentiation. See here, this loss by z, what it is happening, it is going to update with the help of, see here, this is what known as chain rule. So this can be also written as, okay, this both z and z gets crossed. Okay, and you will get this one, right? Can you understand? The derivative of loss with this value, okay, when you cross this, so based on it, it is going to do this chain rule. So when you imagine a multiple neural network, okay, multiple layers, it is going to go back in that way by updating the weight. Okay, these are a little bit complex maths which I don't want you to confuse much more. Okay, so there is something known as chain rule. This value can be written as this value, and you know these values, you can update it and get the value for the new weight. So with that you can reduce the loss. So we'll see a recap, guys. Okay, so just for the clarification, we'll see a recap. So what is a forward propagation? From the input, weights are multiplied and bias is added and given to the activation function, you will get the output. This is what known as forward propagation. When you go for backward propagation, the output, the loss is calculated, and then optimizers, they will add new weight and bias. How they are doing? With the help of chain rule. Okay, and once you will go back into the input, some with different weight and bias. With that, forward propagation will again happen, and this task will keep on going till you reach a global minima or less loss. So next we are going to cover what are the types of activation function, loss function and optimizers. You have to select these, guys. How are you going to select it? So that's what we are going to discuss next. Can we see it, guys? Is it clear till now? Can I get thumbs up, guys? Waiting for your response. So moving into next one, guys. So what are the type of, so thanks for the response. What are the types of activation function, loss function and optimizers? And remember, guys, where we are applying this activation function, it is happening in the neuron. Okay, don't get confused. Activation function is happening in the neuron. Loss function, it is used to calculate the loss when you get the output to compare your original answer and the answer predicted by the neuron. What is optimizer? When you have some loss, you are going to update it in backward, and it is done with the help of optimizer. Okay, these three things. Starting with the activation functions available, there is something known as sigmoid, tanh, ReLU, leaky ReLU, softmax and linear. We have we know this, right? Sigmoid. Remember when we have seen the sigmoid? Tell me guys quickly in chat box. Where we have seen the sigmoid? You can remember in few days back we have seen something about sigmoid and we have used it somewhere. Where it is? Sigmoid function. Some kind of regression in the name it comes. It is used for which problem? It is used for a classification. Remember guys, in the help of logistic regression, we use the sigmoid curve. Based on it, we are determining the output. If it is above 0.5, it is 1, or if it is below 0.5, it is 0. We try to classify with the help of sigmoid curve, which is nothing but logistic regression. In same case, we are going to apply it here in activation function. The first one is known as sigmoid. Okay, this is a sigmoid. This is the formula you are applying. Okay, the function. This is the function is happening in the help of sigmoid. If you, for example, when we use this activation function, guys, in a neuron, when you give the input or from one neuron to another neuron, your input is passed. Okay, from that value, a weight is multiplied and a bias is added, and this value now is given to a function, and that value is now passed to this one. Okay, where sigmoid function will take 1 by 1 plus exponential of that value, negative of that value. So this value, if you plot it, it will be in the range in this like this. A sigmoid curve will, you can obtain from 0 to 1. Okay, and we are having a cutoff value which is 0.5. If it is above that, we are going to consider it as 1. If it is below this, we are going to consider it as 0. Okay. So as I told you earlier, when you go for, see here guys, when you go for optimizers, where if you are using sigmoid, okay, what will happen is you are actually updating with the help of chain rule, right, where we are getting the differentiation, okay, or derivative. So if you are taking derivative, if you are using sigmoid, okay, and if you are taking a derivative, when you take a derivative, it will be actually in a value of between 0 to 2.5. So this will be the maximum value of derivative you can obtain when you pass this sigmoid function. And with this 0 to 0.25, there is a problem known as vanishing gradient problem. So what is this vanishing gradient? Imagine this derivative value can be 0 to 0.25. Okay, very less value. So what is happening here in this chain rule? Okay, it is get multiplied. Okay, for example, if you are having very low value like from 0 to 0.25 only, when you try to improve, okay, improve the weight. So what will happen in this gradient descent is, if you are having very low value, this won't improve, okay, this weight won't decrease or increase, it will be stable. Okay, this is known as vanishing gradient problem. Your weight won't get updated efficiently. We are updating the weight to improve the accuracy or reduce the loss, right? During this back propagation, if you are using sigmoid in between here, any of this place, it is not going to improve that. You can get same number of weight because of very low value of change. So this is known as vanishing gradient problem. So there is some places only you have to use the sigmoid. You don't want to use the sigmoid everywhere. If you use that, you will be getting very low accuracy or very high loss. Clear? And to improve that, we use tanh. So this will apply this formula, where here if you take the derivative, it is between 0 to 1. Okay, so this can improve furthermore. So this is not this, see here, this is the curve, but the derivative is from 0 to 1. Here it is 0 to 0.25, but in tanh you can get till 1. That's what the advantage of this one. When you go for ReLU, what is the ReLU function will do? See here, if you are having two values, it is going to take a maximum value of 0, x. So if you are passing an input value which is a positive value, obviously it is the maximum value, so it will take that value. Okay, but if you are passing a negative value, it is going to consider at 0. Okay, what this ReLU function is doing? For example, you are passing it to a neuron. Okay, you are getting from the neuron, you are passing an input, a weight is added, a bias is added, and a function, ReLU function is activated. In this ReLU function, it is going to take a maximum value between 0 and the value you are passing. If the value is positive, it is going to consider that or take that value. If it is negative, which is obviously less than 0, so the maximum value is 0. So this ReLU function will neglect the negative values and take the positive values only. Clear? Clear what is happening? And it may actually, if you are having, like, what is the problem with this relu function is, when you like neglecting these negative values by presenting it as 0, you are actually like making some of the neurons dead actually. So these 0, those neurons are actually dead. They are not going to do anything later on. So this is a problem. To improve that, they have created something known as leaky relu. So what does this leaky relu do? Instead of 0 comma max, it is going to take a maximum value of 0.1 into x comma x. So the value you are passing, okay, it will multiply with 0.1, so this will be a lesser value comma x. So if it is a negative value, it can be like this, okay, a little bit lower than 0, not that much less. But if it is a positive value, it will be the maximum value, so it will be considered. Okay, this is what known as leaky relu to avoid this dead neuron problems. And then something known as softmax. This is important in some cases. So what we'll do, this will apply this formula where it is going to, if you have got this output, it is going to take the probability by doing this task, and based on the probability it's going to give you the output. So this is softmax. Actually this is used in multi-class classification problem. I'll discuss about that, when to use which function. And finally linear activation, guys. So this linear activation function has nothing to do, okay, this doesn't do anything to it, okay, so it just sum up the value and give the output. That's what is linear activation. So finally, to sum up with, we have seen 6 types, okay, so how to use or how to select it. In case you are going with a binary classification problem, binary classification, either 1 or 0, cat or dog, yes or no, in that question choose relu or leaky relu kind of things in the hidden layer. So in the hidden layer you have to choose the relu or leaky relu because you want to pass the information. But in the output layer, go for sigmoid. Why we are going for sigmoid in a binary classification? Tell me guys in chat. For a binary classification problem, we are going for sigmoid in the output layer alone. Why? Because in the output we want to take either 0 or 1. So with sigmoid, with that sigmoid curve, if it is above 0.5, it will give us 1, or if it is below, it is going to give you a 0. So this will be best if you place it in output layer. Clear? When you go for a multi-class classification, for example, like we had some iris data set, right, where we had 3 classes. What it is? Setosa, vesicular, virginica. In these 3 you want to predict. This is a multi-class classification. It can be 3 or 4 or 5, whatever may be. So in the hidden layer you can use relu, leaky relu and something like that. But in the output you have to go for softmax activation. Why? So in softmax it is going to take the probabilities. So based on it, which is high, that will be the output for you. Okay, if you are having 5 output, it is going to decide which one is most and give you the output. Okay, in case of binary classification, go with relu, leaky relu in hidden layer and sigmoid in output. In case of multi-class classification, use relu and leaky relu in hidden layer and softmax in output layer. So in case you are going with the regression problem, choose the linear activation function in the output layer. Hidden layer you can choose any of these things. Okay, is it clear guys? Can we go and see the last function? Did you guys understand about those things, about the activation functions available and when to use which one? So going with last function, where this last is used, this last function is used in final calculation. Once you get the output, you are going to compare with the original answer. So you are having mean square error, mean absolute error, binary cross entropy and categorical cross entropy. What it is? So if you are having a regression problem, you have to apply either mean square error or mean absolute error. We know this, right? So it is going to take the square error or absolute error using this formula. If you are going for a binary classification like yes or no or 0 or 1 problem, okay, you have to go with binary cross entropy. So these things, how we are going, we'll see that later guys. So we are going to use a library, we'll be applying in Python. So no issue about it. This is just the max or how to use, when to use. So for binary classification, go with binary cross entropy. This will perform this task. If you are going for multi-class classification, then you have to go with categorical cross entropy. Okay. This is for multi-class classification problem. So I hope we can cover these 3. Is it clear regarding the last function, when to use which one? Finally the optimizers guys, we already seen the gradient descent and this one is the best guys. There are something also, but this Adam optimizer is considered as the best till now. So in gradient descent it is going to update the weight and get the global minima or less error. Okay, by updating the learning rate, using the learning rate, it is going to do it. When you go for Adam optimizer, it is going to update the weight. Okay, with that it is going to adjust this learning rate. So this learning rate is constant in this kind of optimizer. But in case if you are going for Adam optimizer, it is going to adapt and execute it by taking exponential average. I hope we have learned about exponential average in yesterday's class, moving average, right? So it is going to take an average of both and give you that value. So based on that task only, both the weight and bias along with that learning rate is also adjusted, so that you can get a better descent curve to get the global minima. Okay, so these are the basic terms, guys. So I hope we are clear. Okay, once again going with the recap, we have seen forward propagation, backward propagation, bias, weight, activation function, optimizer, loss function. Clear? So how are we going to actually perform it? Okay, so for that we are going to use libraries like TensorFlow and Keras. Okay, these are famous libraries used for deep learning purpose. To get neural network, to get these neurons, to get these functions, you can use these. So to install, you can install them separately, but Keras is available in TensorFlow itself. You can install them separately, or in a combo you can do it. Pip install Keras, pip install TensorFlow. So the types of neural network, guys, we are having artificial neural network for these kind of tasks. If you are giving like machine learning things to the artificial neural network, you can do this. And there is something known as convolutional neural network, which has some advantage for doing it for image classification. If you are having 1000 dog image, 1000 cat image, you can give it to the CNN, convolutional neural network, to train. So that once it is trained, okay, based on this backward propagation, all these things, finally when you give a new image, it is going to predict whether it is a dog or a cat based on the image. So we are using convolutional neural network there, and finally we are having recurrent neural network for some other task like NLP. We will discuss about that. So this artificial neural network, see here how I am creating. So tomorrow we will be going hands-on, where I will show you how it is done. So from Keras we are importing sequential, and this sequential is like for creating a neural network, and dense is something like a layer. So in this dense, okay, first I am creating a model with sequential. In this sequential I am going to add dense layer. So this dense layer is a single layer, where if I set 64, which means 64 neuron, and see here I am setting an activation function relu. So this is where you are setting the activation function and the dimension you are mentioning. And this I am adding another input, another hidden layer. This dense is known as hidden layers. They are also 64 unit. I am setting it as relu. Finally you should have an output layer. So where you want to mention, okay, so the output is, you are adding the dense layer, finally will be output. And here, see here guys, the activation I am using is softmax. What is this softmax? It is used for classification, right? Multi-class classification. And see here when I compile, this is like setting the tasks, okay, and the optimizer I am setting is Adam optimizer. See here I am mentioning Adam. And the last value I am setting is categorical cross entropy. We know this, right? So this activation function is for multi-class classification. This loss is also for multi-class classification. And the metrics I am using here is accuracy, to calculate the accuracy. Once I fit all these things, I am just going to fit the model, give the X train, Y train, and something known as epoch and batch size are there. We will discuss about that in tomorrow's class. And once you fit the model, it is going to train, okay, by doing both forward and backward propagation many times. Okay, finally we can get prediction with the help of dot predict. So when you go for CNN, so like this, it is going to take a kernel and do some tasks. We will discuss about that layer detailedly. Here it will do all this from one layer to another. It is going to pass the information from that image. There is something known as pooling, okay, and all these things will happen. And finally we will be having an output, okay, based on the percentage. So CNN are unique architecture. So it is used for image classification kind of tasks. So for convolutional neural network, there is something known as convolution 2D, max pooling 2D. These are some layers. So in same way we are going to add them. Finally we are going to use same optimizer. See here guys, the activation function, optimizer and loss, they will be what we have seen in today's class only. Whether it is CNN or ANN or RNN, they will be same. Or based on the task you are going to select it. Finally RNN, it is for like natural language processing, time series data, audio signals, etc. Okay, so this there are some tasks like LSTM. Okay, there are some types are available, and this is the same method, guys. You will get sequential and add the layers, add the activation. See here, guys, this is something like a classification problem, binary classification. So the activation is, we are mentioning sigmoid, and the optimizer is Adam, and the loss is binary cross entropy, because it is a binary classification. Finally, we are fitting and getting the output. So in tomorrow's class, guys, we'll try to do this task hands-on by seeing a project by applying a artificial neural network. Clear, guys? Thank you. Thanks for watching. If you guys have any doubt, you can ask in this time. I hope the attendance will be updated soon. So please wait. In the meantime, you can ask for any doubt if you have. Otherwise, we can wind up today's session. Okay, you are asking building a predictive system based on the assignment, right? Okay, so when you go for a predictive system, you have to actually get the input data by, for example, if you are trained your model with 8 features, you need 8 features or 8 values to actually pass it to the model. So you have to create an input, and then you have to convert it to an array, and then reshape with 1 comma minus 1, which means 1 row and all the column, and then you have to pass it with model to dot predict. So that will give you an answer. So once you got the answer, you can actually decide which is the output. Explain regression model. Can you please tell me which regression model exactly? Is it based on today's class or what? Regarding LSTM, we can see it in separate class, guys. So this is just an introductory class where I just want to brief you about all the terms like forward, backward propagation, optimizer, learning rate, activation function, and so on, loss functions. So in tomorrow's class, when we see project, okay, we'll include CNN, ANN, and LSTM, and at that time I'll explain you about how they are working. Okay, I don't want to imply everything in single class. It will be a little confusing for others.